Welcome to lesson number 6, module 1 of the Big Data Hadoop developer course. So in this particular lesson, we will be introducing Hadoop. So before we proceed with the lesson, let's have a recap of the previous lesson. So in the previous lesson, we have seen what is real-time and batch processing and terminologies such as scale up, scale out, OLAP, and OLTP. So in this particular session, we will be covering the limitations of the existing RDBMS systems and introducing Hadoop. We'll see the key features and history of Hadoop and big data job market and predictions. So we have traditional systems and new systems. Now, when you say traditional systems, the traditional systems usually depend on a single machine. So no matter you're talking about a web server or an application server or a storage server, usually it is done, the activity is done on a single machine. That means, just like we have seen in the previous lesson, it is limited to scaling up. So as the user data or the user traffic increases, and as in where there is a huge demand for processing, these systems might fail because there is always a ceiling for the amount of resources that you can put inside a single machine. And the cost of the system is also considerably high. For example, if you want to set up a Oracle database server, then you cannot use the regular low or a cheap grade hardware for that. You should be shelling out a lot of money for that as well. Whereas if you compare this with something called the new system, the new systems basically work on the distributed computing principle. Now here, rather than depending on a single machine for doing all the job, we can have machines which are less powerful, but the number of machines can be more. So rather than depending on a single machine for doing the job, we can have maybe 3 machines or 5 machines which can split the task and work for us. Now the advantage of this particular strategy in the new machines is that you are practically no longer limited by scalability. You can expand to as many machines as you want to accommodate the changes that you need. So let's have a look at what exactly is Hadoop. Now Apache Hadoop is an open source framework which we use for storing and processing big data. Now the Hadoop is a framework which is originally developed by two folks called Mike Cafrilla and Doug Cutting, and later on adopted as an Apache open source project. Now, when I say Apache Hadoop is open source, you are free to download and use it, and also the source code is available so that you can modify that if you want. Now, the Hadoop also allows distributed storage and distributed processing of large data sets across clusters of commodity computers using a simple programming model. Now, what does that exactly mean? Hadoop allows you to store the data and process the data inside the same cluster. So whenever we think about big data, the biggest problems are where you will store it and how do you process it. Now Hadoop gives you a single shot solution wherein the same cluster can be used for raw storage and processing as well. Now the key point that you have to note down here is that commodity computers. Now commodity computers means low and cheap servers. For example, entry-level servers. If you look at any traditional solution for storing and analyzing data, such as Oracle, Teradata, Exadata, or any sort of databases or lab machines, they all require high-end servers to be part of the hardware. Now Hadoop doesn't mandate that you should be using a really costly machine to set up your cluster. You can very well use any type of hardware that is available to you, and in most of the production we use low grade cheap hardware servers to set up Hadoop. Now this is the biggest advantage of Hadoop, since the cost of the hardware can be considerably saved by doing this. Let's have a look at some of the key features of Hadoop. So first of all, it is based on the master-slave architecture. So it is neither grid computing or massive parallel processing. It is nor one-to-one or peer-to-peer processing. This is based on the best of both worlds, that is called the master-slave architecture, where you have a dedicated node for controlling the slave nodes, and it is designed for massive scale, in the sense like practically you can have unlimited number of machines inside a Hadoop cluster. High availability and fault tolerance are built into Hadoop. Now you might be wondering, if I have, for example, hundreds of servers in my Hadoop cluster, and if I am using the commodity hardware machines which are very cheap, then at some point of time they are expected to fail and give me problem. Now Hadoop has built-in operations to prevent this, such as it enables replication to give you fault tolerance and high availability. We will have a look at this in the upcoming lessons. And there is low software and hardware cost for Hadoop, and the storage and processing is distributed, and there is no license cost, supported by a very large developer community. So here we can have a look at some of the big names in the industry who are using Hadoop, such as Tesco, IBM, Cisco, Dell, LinkedIn, Hortonworks, and Microsoft itself. Now, there are a lot of questions about Hadoop, and one such question that we used to get is that, is this technology here to stay, or is it something which is going to lose the interest over a period of time? Now, this is a technology which is going to stay here. The reason behind that is that since Hadoop is an open source project, most of these companies have invested a lot of money and manpower incorporating latest features into the upcoming version of Hadoop. So that means Hadoop is not designed by a set of people or a company. It is designed by the top level companies in the entire world by putting their effort, manpower, and suggestions. And year by year, these contributions from different players in the industry gets increased. Now, if you look at the history of Hadoop, we can see very well that in 2002 and 2003, there were two folks called Doug Cutting and Mike Caffarella, and they were working on a search engine called Nutch. At the same time, Google had released two white papers called the GFS and MapReduce white papers. Now, Google, being a pioneer in data storage and analysis for their search engine, was using something called Google File System to store this massive amount of data, and another framework called MapReduce for processing the same. Now, Google had revealed its secret in 2003-2004 by exposing two white papers to the public. Now, at the same time, Doug and Mike were working on another search engine project called Nutch. They started building a strong foundation for their search engine using GFS and MapReduce, and that is how the first version of Hadoop was born. Now, once Hadoop was born, immediately after that, Yahoo hires Doug Cutting, and HDFS and MapReduce are created. So the first version of Hadoop got released in 2005-2006. After that, you can see that in 2007, New York Times uses Hadoop to convert some of their image archives. In 2008, Facebook launches a tool called Hive. And in 2009, there was a Hadoop summit with 750 attendees. And in 2011, Doug Cutting joins Cloudera. And in 2011, we have Hadoop 1.0 version. Now, as you can see, the Hadoop version 2 was released in 2013. So this is a brief history of Hadoop. Now, some of the small use cases of Hadoop, Spotify uses a Hadoop cluster of 1650 nodes or machines. They have 43,000 virtualized cores, 70 terabyte of RAM, and 65 petabytes of storage. Now, they run close to 20,000 daily Hadoop jobs, and they use Hadoop for content generation, data aggregation, reporting, etc. LinkedIn uses three specific Hadoop clusters, one with 800 nodes, another with 1900 nodes, and another with 1400 nodes. And you can very well see the configuration of the individual nodes in this picture. Now, LinkedIn uses Hadoop heavily for their features such as people you may know. If you add if you accept a connection request from a person in LinkedIn, you will be immediately shown suggestions as to people you might know. So this feature is actually suggested by data analytics inside Hadoop. So to wrap up in this particular lesson, we have learned the limitations of RDBMS solution. We have introduced Hadoop and the key features of Hadoop, and we had a look at two Hadoop clusters across the world. That's all for this lesson. If you have any questions, please do not hesitate to raise a support ticket. Thank you.